All right, welcome back, everyone, for part 2 of our deep dive into enabling 369 Superflight.
Exactly. It's getting down to the nitty-gritty.
Yeah, last time we sort of mapped out the journey, and today we're really getting into those core elements, right?
Absolutely. Think of it as like we're really laying the foundation and we have to go row by row to cross-check that maturity capability.
Yeah, and today's foundation, I guess you could say, is all about data storage.
The hidden infrastructure, right?
Yeah. It might not be the most glamorous topic, but trust me, it impacts everything.
It does, from performance to cost, security, scalability.
Yeah, so no matter how fancy our AI models get, if the data storage can't keep up.
It's like building a race car with a bicycle engine. It just won't work.
Exactly. Okay, so we're going row by row through this capability framework.
Deep dive.
Deep dive. And for each one, we'll talk about how we discover what's already there, how we tag things to make them findable later, where the expertise is coming from, and finally, the storage itself.
Sounds good.
All right, let's start with data lineage tracking. Now, you've worked with tons of complex data systems. Have you ever had trouble tracing where data came from or how it's transformed along the way?
Oh, absolutely. It's incredibly common, and it can turn into a real nightmare, especially when you're dealing with AI models that are heavily reliant on data quality.
Right, so how do we even begin to untangle this data spaghetti, as I like to call it? The table mentions tracing data flow across different sources, structured and the unstructured.
So think about customer data, right? It could come from your website, your mobile app, and each of those is going to have its own quirks, its own format, and then you add in your CRM system. Data lineage is about mapping all that out.
So it's like creating a map of the data's journey.
Exactly. And we need the right breadcrumbs along the way.
I see. Like the tags mentioned here, data.lineage, data.source, and data.transformation.
Precisely. So we know not only where it ended up, but every stop along the way.
And this isn't just a technical thing, right? We need the right people involved.
Absolutely. The enterprise data governance team, they're the keepers of data quality and best practices.
Makes sense. They know all the ins and outs of data handling policies.
Regulations, too.
Right. Okay, but what about the storage itself? The table mentions AWS, Glue Data Catalog, OpenSearch, and even Neptune, which is a graph database.
Well, each tool brings something different to the table. Glue Data Catalog, that's like our central inventory for our data assets.
Makes sense.
OpenSearch lets us search through massive amounts of that lineage data quickly, and then Neptune helps us visualize those relationships.
So it's like having different lenses to look at the same data.
Precisely. The key is to use the best tool for the job.
All right, next up on our list is model versioning and management. Now, I'm sure you've seen firsthand how quickly AI models can evolve, right?
Oh, yeah. It's constant.
So how do we keep track of all those changes without ending up in a chaotic mess? Because I can imagine you deploy a model into production, and then weeks later, you realize there's a bug or a regulation changed.
It happens more often than you'd think. Without proper versioning, it becomes a nightmare.
So it's not just about keeping track of different versions, but also being able to easily switch back and forth if needed.
Exactly. And tagging is crucial here. The table suggests tags like model.version, model.date, model.author.
Oh, so we can see who created the model, when it was trained, what data was used.
Exactly. Even how well it performed. We have tags for that too.
Smart. Now, this seems like it would fall heavily on the Enterprise AML Center of Excellence.
They're the experts in model development and lifecycle management.
And for storage. The table points to SageMaker Model Registry and DynamoDB.
So SageMaker Model Registry is purpose-built for this. Think of it like a sophisticated filing system for your models. You can always access the right version, see its history.
It's capturing all the context around it.
Precisely. And then DynamoDB, that gives us the speed and flexibility to access that metadata about the model.
Okay, I'm starting to see how these different tools can work together.
The synergy is key.
All right, let's move on to feedback mechanisms for users. Now, I know user feedback is crucial for any software application, but it's especially important for AI systems that are constantly learning, right?
Absolutely. User feedback is like a constant stream of insights, helping us improve the model over time.
So the table mentions identifying existing feedback channels. Are we talking surveys, feedback forms, even just emails?
We need to look at everything. How are users providing feedback now? What kind of info are we capturing? Are we getting numbers like ratings, or are we getting more descriptive comments?
So we need to know both what we're getting and how we're getting it.
Right. Then we can look at how to organize it. The table suggests tags like feedback.type, feedback.content, feedback.date.
So we can filter it by the type of feedback, the content of the feedback when we got it.
Exactly. And to make sure we're actually capturing what's useful, we need to collaborate with the business unit they know the user needs.
And for storage, the table mentions a feedback store and DynamoDB. I'm guessing they serve different purposes.
The feedback store would be like a central repository for all the data. DynamoDB is great for real-time access.
So if we have a chatbot that needs to adjust its responses based on user feedback, DynamoDB can provide that instant insight.
Precisely. It's about having the right tool for the right job.
Okay, next up we have bias detection and mitigation. This is a topic that's been getting a lot of attention lately, and for good reason. We all know that AI systems can inherit biases from the data they're trained on. How do we even begin to tackle that?
Well, it starts with the data itself. We need to analyze who's represented in the data, the language used. You have to remember, even subtle things can reflect historical biases.
So it's not just about looking for obvious biases like gender or racial biases, but also about understanding the subtle ways in which language and data can perpetuate inequalities.
Exactly. And our tagging strategy reflects that. We have bias.type, bias.impact, bias.mitigation.
So we're not just identifying the bias, but also how we're addressing it.
Right. And we need a mix of expertise here. The Enterprise AML Center of Excellence for the technical side of things.
And legal team, I'm guessing, to make sure we're meeting all the regulations and ethical standards.
It's a delicate balance for sure.
And for storage, the table recommends SageMaker Clarify and OpenSearch. What are your thoughts on that combination?
Well, SageMaker Clarify is specifically designed for bias detection and mitigation. It gives us insights into how the model is behaving and helps us pinpoint areas for improvement.
It's like a bias detective.
And then OpenSearch lets us store and analyze those bias metrics over time so we can see how things change as the model is used and updated.
So it's not just a one-time check, but continuous monitoring.
Exactly. It's about being proactive and data-driven in our approach to bias mitigation.
All right, let's move on to explainability and interpretability. Now, this is a big one. AI is getting more complex, and it's more important than ever to understand how those systems are making decisions, right? Especially if those decisions have real-world impact.
Absolutely. We need to be able to explain not just what the AI decided, but why it decided that. It's crucial for building trust, ensuring fairness, and even just debugging when things go wrong.
The table mentions identifying the types of explanations needed for different use cases. Can you give us an example of how those explanations might differ?
Sure. Let's say you're using an LLM to assist doctors in diagnoses. You need an explanation that a doctor can understand.
Right. It can't just be a bunch of code or numbers.
Exactly. And it might need to reference medical literature, show the model's confidence level, things like that.
So the explanations need to be tailored to the specific audience and context.
Exactly. And the tags here help us manage that. Explanation.type, explanation.method, explanation.target.
So we can categorize explanations based on their purpose, how they were generated, who they're for. That's smart.
Organization is key.
Right. And I imagine this leans heavily on the expertise of the Enterprise AML Center of Excellence.
They have the know-how in explainable AI frameworks. They know all about things like LIME and SHAP.
So these are tools or techniques that help us understand how the model is making its decisions.
Exactly. They help us pinpoint which features are most important in the model's prediction.
Interesting. And for storage, the table suggests AWS Kendra and S3. Why this combination?
Think of Kendra as a supercharged search engine for explanations. It can store not just the explanation itself, but all the documentation, relevant materials.
So if someone needs to understand why the model made a certain prediction, they can use Kendra to find all the supporting information.
Precisely. And then S3, that's where we can store the larger files, things like visualizations or reports.
Okay, so it's a two-pronged approach. Quick access for simple explanations via Kendra, and more in-depth resources stored in S3.
It gives us the flexibility to handle different levels of complexity.
All right, I think we've covered a lot of ground already, but we're just getting started. Our data storage journey continues next time we tackle monitoring and logging.
See you then.
All right, until then, thanks for listening, everyone.
Keep exploring.
Welcome back to our deep dive into enabling 369 Superflight. Last time we were talking about explainability and interpretability of our AI models. Let's move on to something that might sound a bit like Big Brother, but is super important: monitoring and logging.
Absolutely. You can't just set these things loose and hope for the best. We need to know what's happening in our LLM and ARG applications, how they're performing, and whether there are any security issues.
So it's like having a constant stream of data coming from a spaceship, letting us track its trajectory, right?
That's a great analogy. We need that telemetry to spot anomalies and make course corrections.
Okay, the table says we need to figure out what's already being monitored and logged. Are we collecting the right data? Are there any gaps?
Right. Are we capturing those key performance indicators like response times, accuracy, error rates? And are we logging security events like someone trying to access the system who shouldn't?
Makes sense. We can't analyze what we're not capturing. Then there's the tagging, log.type, log.content, log.date, log.user, log.use case. It's a lot.
But it's necessary. That level of detail lets us filter and analyze the data effectively. Imagine sifting through mountains of logs. The tags are like little flags that help us find what we're looking for.
So it's like having a superpowered search function for our logs. Makes
Yeah.
sense. And I imagine this is where enterprise IT and security come in.
Absolutely. IT manages the infrastructure and security analyzes those logs for potential threats. They need to work closely together.
Great. And what about storage? The table says CloudWatch logs and OpenSearch.
CloudWatch Logs is like that giant logbook, right? A central repository for all that data. Then OpenSearch lets us really dig in, search, analyze, and extract insights from that data.
So it's not just about storing the logs, but also being able to make sense of them, to find the needle in the haystack.
Precisely. We need both the raw data and the ability to understand it.
Okay, on to a topic that's always on my mind, especially with powerful AI systems. Cost management and optimization. We've got to keep a close eye on those cloud bills.
Absolutely. These LLMs and RAs can be resource intensive, so cost management is critical. We need to find that sweet spot between performance and cost effectiveness.
Right, we don't want to skimp on performance, but we also don't want to break the bank. The table says we need to analyze spending patterns and identify areas for potential savings. Where do we start?
We have to understand our usage patterns. Are
Yeah.
we using more resources than we need? Are there times of day when we could scale back? Maybe there are opportunities to leverage spot instances or reserved instances to reduce costs.
So being smart about when and how we use resources.
Exactly. And don't forget about optimizing our code. Even small efficiency improvements can lead to significant cost savings over time.
And I see we have a whole bunch of tags here again. Cost.type, cost.category, cost.date, cost.model, cost.use case. It seems like detail is key.
It is. That level of tagging allows us to track costs very precisely. We can see exactly where our money is going and identify areas where we can cut costs without sacrificing performance.
So it's like having a financial microscope, letting us zoom in on individual cost drivers.
That's a great way to put it.
This seems like another area where collaboration is key.
Definitely. We need both enterprise IT and finance involved. IT understands the technical side of cloud infrastructure and optimization, while finance can provide guidance on budgeting and cost allocation.
Great. What about the storage itself? The table recommends AWS Cost Explorer and CloudWatch metrics.
Cost Explorer is purpose-built for cost analysis. It's like having a financial dashboard for our cloud usage, showing us how much we're spending, where the money is going, and how costs are trending over time.
That's incredibly helpful. And CloudWatch metrics.
That gives us real-time visibility into resource utilization. We can see how much CPU, memory, and storage our LMs and our GIs are using, which is crucial for identifying optimization opportunities.
So it's like having a speedometer for our cloud resources. We know how fast we're going and can adjust accordingly to stay within our budget.
Exactly. Data-driven cost management is the key to maximizing the value of our LLM and R8 investment.
Okay, on to scalability planning. We all know that AI applications can grow very quickly, both in terms of the amount of data they process and the number of users they serve. How do we ensure our infrastructure can keep up?
Scalability planning is crucial. We need to anticipate future growth and design our systems with that growth in mind. It's like building a bridge. You don't just design for today's traffic, but for the traffic you expect 5 or 10 years down the road.
That's a great analogy. The table says we need to figure out our current capacity limits and project those future growth requirements. How do we do that?
We start by understanding our current usage patterns. How much data are we processing now? How many users are accessing our LLMs and REGs? When do we see those peak usage times? Once we have that baseline, we can start to project future growth.
So we're gathering data to understand the present and then using that data to model the future.
Precisely. And the tagging strategy here helps us track our scaling efforts and understand their impact. We have tags like scale.type, scale.capacity, scale.date, and scale.performance.
So it's not just about scaling blindly, but also about measuring the impact of those changes and making adjustments as needed.
Exactly. We need to be data-driven in our approach to scaling, just like we are with cost management.
Makes sense. And I'm guessing enterprise IT plays a big role here.
Absolutely. They're the experts in designing and managing scalable cloud architectures.
What about storage? The table recommends DynamoDB autoscaling and AWS autoscaling for compute resources.
DynamoDB autoscaling is fantastic because it allows our storage to grow and shrink dynamically based on demand. We don't have to over-provision resources and end up paying for capacity we're not using.
So it's like having an elastic storage system that expands and contracts as needed.
Exactly. And AWS autoscaling does the same thing for our servers. It automatically adds or removes servers based on demand, ensuring we have the right amount of computing power at any given time.
So it's like having an elastic fleet of servers that can scale up or down to meet those fluctuating demands. I'm starting to see a pattern here.
It's all about building flexible and dynamic systems that can adapt to changing conditions. That's what true scalability is all about.
Okay, let's move on to integration with existing workflows. We all know that AI systems don't exist in isolation. We need to make sure our LLMs and RGAs can play nicely with all the other systems and processes that keep our business running.
Absolutely. Integration is crucial for maximizing the value of our LLM and RGA investments. It's about weaving these powerful AI capabilities into the fabric of our existing workflows, making them accessible and usable across the organization.
The table mentions discovering existing workflows and identifying potential integration points. What are some common integration scenarios we might encounter?
Imagine you have a customer service chatbot powered by an LLM. To be truly effective, that chatbot needs to integrate with your CRM system to access customer data, your ticketing system to create support tickets, and your knowledge base to provide accurate information.
So it's about creating a seamless flow of information between different systems, ensuring that our LLMs and RAGs have access to the data and services they need to do their jobs effectively.
Exactly. And the tagging strategy here helps us track those integrations and understand their impact. We have tags like integration.system, integration.type, integration.date, and integration.api to document which systems are being integrated, the type of integration, and the technical details involved.
So it's like creating a roadmap of our integrations, showing how different systems are connected and how data flows between them.
Precisely. And for this, we'd need expertise from both the business unit and enterprise IT. The business unit understands the business processes and workflows that need to be integrated, while IT has the technical know-how to make those integrations happen.
Makes sense. It's a partnership between business and technology to ensure that our AI systems are truly integrated into the heart of our operations. But what about the storage itself? The table mentions Amazon API Gateway and EventBridge. Why these services?
Amazon API Gateway provides a secure and scalable way to manage APIs, which are the interfaces that allow different systems to communicate with each other.
So it's like a traffic cop for our APIs, directing traffic and ensuring that only authorized systems can communicate with each other.
Exactly. And EventBridge enables event-driven architectures, allowing different systems to communicate and trigger actions based on specific events.
So it's like a message bus that allows different systems to publish and subscribe to events, enabling them to respond to changes in real time.
Precisely. This combination of API Gateway and EventBridge provides a flexible and powerful framework for integrating our LLM and RAG applications into our existing workflows, ensuring seamless data flow and efficient communication between systems.
Okay, I've always said that even the most powerful AI is useless if people don't know how to use it. So let's talk UI design for LM or RAG apps.
UI design is often overlooked, but it's absolutely crucial. We need interfaces that are intuitive, engaging, and meet the specific needs of our users.
Right, it doesn't matter how smart the AI is if the interface is clunky and frustrating. So the table says we should look at our existing UI UX guidelines and identify areas for improvement. Are we following best practices for AI-powered interfaces?
Exactly. We need to ask ourselves, are our interfaces easy to navigate? Are the interactions clear? Are we providing appropriate feedback to the user? User feedback is incredibly valuable here.
And the table recommends tagging UI elements with wi.type, y.feature, where.date, and wi.user. I'm sensing a theme here with all these detailed tags.
It's all about tracking, analyzing, and understanding. Those tags allow us to see how our UI is evolving, what changes are being made, and how those changes are affecting the user experience.
So we have a record of how the design has changed and can see if those changes are actually improving usability. That's pretty smart.
It's all about data-driven design.
Makes sense. It feels like a partnership between knowing what users need and then designing something that actually meets those needs.
Absolutely. You need both the business understanding and the design expertise to get it right.
And for storage, S3 for front-end assets, and API gateway for UI LLM interactions. What's the thinking there?
S3 is a great choice for storing those static assets like images, CSS files, JavaScript, all the building blocks of the front end. It's reliable, scalable, and cost-effective.
So it's a digital warehouse for the UI. And what about API gateway?
API Gateway is the bridge between the UI and the LLM, handling those interactions securely. It takes care of things like authentication and makes sure the system is protected from getting overloaded with requests.
So it's a gatekeeper, making sure everything runs smoothly and securely.
Precisely.
Okay, let's talk APIs, API management. They're the unsung heroes of the software world, connecting different systems together. But we need to make sure they're being managed properly, especially when we're dealing with powerful AI like LLMs and ARG.
Absolutely. API management is crucial for controlling access to our LLM and ARG capabilities, ensuring security and maintaining performance. Think of it like air traffic control for our APIs.
I like that. Directing traffic, enforcing rules, preventing collisions. The table suggests we look at our existing API management practices. Are we using things like API keys and rate limiting?
Right. Those are essential security measures. We need to make sure we're authenticating requests properly, protecting against overload, and monitoring for any suspicious activity.
And of course, more tags. API.name, API.version, API.security, API.rate limit. Why is this level of detail so important?
It's about accountability and insight. We can track which APIs are being used, who's using them, how often they're being called. If we see any unusual activity, we can investigate and take appropriate action.
So it's like having a detailed logbook for our APIs, showing who's accessing what and when.
Exactly. And for this, Enterprise IT is our go-to team. They're the experts in managing APIs and ensuring security.
Right. What about storage? The table mentions Amazon API Gateway and Lambda.
API Gateway is really the central hub for API management, handling authentication, rate limiting, and a lot more.
So it's like the command center for our APIs.
And Lambda allows us to run code in response to events. It's incredibly versatile. We can use it to validate requests, transform data, or trigger other actions based on what's happening with our APIs.
So it's like having a team of programmable assistants that can automate all sorts of API-related tasks.
It's a powerful combination that gives us a lot of flexibility and control.
Okay, let's shift gears a bit and talk about something that might sound a bit dry, but is super important. Data governance policies. We've talked a lot about the technical side of data storage, but we also need to make sure we're using data responsibly and ethically.
Absolutely. Data governance is all about establishing a framework for managing data throughout its entire life cycle, from the moment we acquire it to the moment we dispose of it.
So it's not just about security, but also about privacy, compliance, and ethics.
Exactly. We need to think about things like, are we following all the regulations? Are we respecting user privacy? Are we using data in a way that aligns with our values?
The table suggests we start by looking at our existing data governance policies. Do we have any gaps? Are there areas where we need to improve?
It's about taking stock of what we're doing now and identifying areas where we can do better.
And we have some familiar friends in the tagging department: data.governance, data.policy, data.sensitivity, and data.retention.
Those tags help us categorize data based on its governance requirements. We can track where data came from, how sensitive it is, and how long we need to keep it.
So it's like creating a data inventory that's also a guide to how that data should be managed.
Exactly. And this is definitely an area where we need to collaborate closely with enterprise data governance and the legal team. They're the experts in navigating this complex world of data governance and compliance.
Makes sense. What about the storage itself? The table recommends AWS Lake Formation and Glue Data Catalog.
Lake Formation is a service that makes it easy to set up a secure data lake in the cloud. It helps us control access, enforce those governance policies, and prepare data for analysis.
So it's like the control panel for our data lake, right?
That's a good way to think about it. And Glue Data Catalog is like a map of our data lake. It provides a unified view of all our data assets, making it easier to find what we need and understand what we have.
It's like having a data librarian who knows where everything is.
Exactly. This combination helps us ensure that data is being managed responsibly and ethically.
Okay, on to another crucial aspect: access control and authentication. We need to make sure only the right people and systems can access our LLM and RAG environments and that precious data.
Absolutely. This is fundamental security, especially with powerful AI technologies that can access and process sensitive information. We need to lock things down tight.
The table suggests we should understand our existing access control mechanisms. Are we using role-based access control, multi-factor authentication, or other security measures?
Right, we need to know what we're doing well and where we have weaknesses. Are we effectively limiting access to sensitive resources? Are we making sure that users are who they say they are?
Multi-factor authentication is always a good idea, right?
Absolutely. It adds an extra layer of security that makes it much harder for unauthorized users to gain access.
And more tags. Access.level, access.role, access.permission, and access.method.
These help us track access attempts and understand how people are using our systems. If we see any unusual activity, we can investigate. It's all about being proactive.
And enterprise security is our primary knowledge source here, right?
Absolutely. They're the experts in access control and authentication.
What about storage? The table recommends AWS IAM and AWS Cognito.
IAM, or Identity and Access Management, is the heart of AWS security. It lets us define very fine-grained permissions, controlling who can access what resources.
So it's like having a very strict bouncer at the door, checking everyone's ID and making sure they're allowed in.
That's a great analogy. And Cognito helps us manage user sign-up, sign-in, and those multi-factor authentication processes I mentioned earlier.
So it handles the entire user journey from registration to login and ensures that access is secure throughout the process.
Exactly. It's a powerful combination for managing users and securing our AI systems.
Okay, speaking of securing data, let's talk about data encryption and masking. This is about protecting sensitive information both at rest and in transit.
Absolutely. Encryption scrambles data, making it unreadable without the proper key. Masking replaces sensitive data with fake data that still looks realistic.
So it's like putting sensitive information in a locked safe and then disguising the safe so no one even knows it's there.
That's a good way to think about
The
it.
table suggests we should understand how we're currently using encryption and masking. Are we encrypting data at rest? In transit? Are our masking techniques robust enough?
We need to make sure we're using industry-standard encryption algorithms and that our keys are managed securely. And our masking techniques need to be strong enough to protect against any attempts to identify or recover the original data.
Right, we don't want anyone peeking behind that mask. And as always, more tags.
Yeah.
Encryption.method, encryption.key, masking.type, and masking.rule.
Those tags help us track exactly how we're protecting data and make sure we're following best practices.
Enterprise security is our primary knowledge source again, right?
Absolutely. They're the experts in data protection and can guide us in choosing the right tools and techniques.
What about storage? The table recommends AWS KMS and AWS Glue data masking.
KMS, or Key Management Service, is all about managing encryption keys securely. It's like having a master locksmith who safeguards those keys and makes sure they're used properly.
So it takes the responsibility of managing those keys off our hands and ensures that they're protected with the highest level of security.
Exactly. And glue data masking makes it easy to apply those masking techniques we talked about. It gives us a variety of options for masking data, depending on how sensitive it is and how we need to use it.
Okay, now let's talk about something that's essential for demonstrating accountability and staying on the right side of the law: auditing and compliance.
Absolutely. We need to make sure our LLM and RAG workflows are not only secure, but also compliant with all relevant regulations and policies. Auditing is how we prove that we're doing things the right way.
The table suggests we should understand our existing auditing and compliance practices. Are we logging events, monitoring user activity, conducting regular audits?
Exactly. We need to know what we're doing well and where we need to improve. Are we capturing all the necessary information? Are our audit trails complete and accurate? Are we conducting audits frequently enough?
And you guessed it, more tags: audit.event, audit.user, audit.date, and audit.compliance. These tags allow us to quickly find and analyze audit data. We can see who did what, when they did it, and whether any actions violated any policies.
Precisely. It's all about transparency and accountability.
And it looks like enterprise security and the legal team are our partners in crime on this one.
Definitely. Security ensures we have the right technical controls in place, and legal guides us on compliance with all those laws and regulations. It's a team effort.
And for storage, we've got AWS Security Hub and AWS CloudTrail.
Security Hub acts as our security command center. It pulls in security findings from various sources, including CloudTrail.
So it gives us a high-level view of our overall security posture.
Exactly. And CloudTrail is the one that's actually recording all those events. It keeps a log of every API call made to our AWS account, which is incredibly valuable for auditing and compliance.
So it's like having a surveillance camera that's constantly recording everything that happens in our cloud environment.
That's a great analogy. We have a complete record of what happened, who did it, and when.
Okay, almost there. One more row to go. Change management process. We know AI is constantly evolving, so how do we make sure that changes are made safely and smoothly without causing any disruptions?
That's where a structured change management process comes in. We need a clear and repeatable process for planning, implementing, and reviewing changes. It's about minimizing risks and ensuring that everything keeps running smoothly.
The table says we need to understand how changes are currently being managed. Are we just winging it, or do we have a formal process in place?
Exactly. Are changes being requested properly? Is their impact being assessed before they're implemented? Are they being tested thoroughly? Do we have a rollback plan in case something goes wrong?
So it's about having a safety net, right?
Mm,
We don't want to make changes blindly and hope for the best.
exactly. We need to be deliberate and thoughtful about how we manage change.
More tags to help us: change.type, change.description, change.date, and change.impact.
Those tags allow us to track changes over time, understand their impact, and identify any patterns or trends.
And enterprise IT is our primary knowledge source here.
Absolutely. They're the ones responsible for managing our infrastructure and ensuring that changes are made safely and responsibly.
What about storage? The table recommends AWS Service Catalog and AWS Systems Manager.
Service Catalog is a fantastic tool for managing standardized IT services, which could include our LLM and RG workflows. It gives us a central place to define, provision, and manage those services, ensuring consistency and compliance.
So it's like a self-service portal for IT services.
That's a good way to think about it. And Systems Manager provides a set of tools for managing systems configurations, automating tasks, and ensuring compliance.
So it's all about bringing order and predictability to the process of managing change.
Exactly. These tools help us minimize risks and keep our systems running smoothly, even as we're constantly innovating and making changes.
Okay, on to a topic that's near and dear to my heart: training and enablement. We've spent all this time talking about building these amazing AI systems, but we need to make sure people know how to actually use them.
You're absolutely right. Training and enablement are crucial for user adoption and success. We need to equip our users with the knowledge and skills they need to effectively leverage the power of LLMs and RJs.
The table suggests we start by looking at our existing training programs. Are we providing adequate training on LLM concepts, use cases, best practices? Are there any gaps in our offerings?
We need to ask ourselves if our training programs are engaging and relevant. Are we providing hands-on exercises and real-world examples? Are we tailoring our training to specific roles and use cases?
And more tags: training.topic, training.audience, training.format, and training.usecase. Why is all this tagging so important?
It allows us to organize our training materials and track their effectiveness. We can see which topics are most popular, which formats are most engaging, and whether our training is actually helping users achieve their goals.
It sounds like we're building a knowledge base of training resources that are carefully curated and tailored to different audiences.
Exactly. We want to make sure that everyone who needs to use LLMs and RAGs has access to the training they need to be successful.
And what about storage? The table mentions S3 for storing training materials and AWS Skill Builder.
S3 is a great choice for storing all kinds of training materials like videos, presentations, documents, code samples. It's like having a giant digital library for all things training related.
And AWS Skill Builder.
That's a fantastic platform for creating interactive, engaging online courses. It allows us to track user progress, provide personalized feedback, and really make sure people are learning what they need to know.
So it's a virtual classroom for LLM and org training. That's awesome.
It's a great way to make training more engaging and effective.
Okay, let's move on to a topic that's been getting a lot of attention lately: prompt engineering. I've heard people call it an art form, a science, even a bit of magic. What exactly is it, and why is it so important when we're talking about LLMs?
Prompt engineering is the skill of crafting effective prompts or instructions that elicit the desired responses from an LLM. It's like knowing how to talk to the LLM in a way that it understands and gets you the output you're looking for.
So it's not just about asking any old question. It's about asking the right question in the right way.
Exactly. The way you phrase a prompt can have a huge impact on the LLM's response.
The table suggests we should understand our current prompt engineering practices. Are we being systematic in our approach, or is it more ad hoc?
Right. Are people just making up prompts as they go along, or do we have some established guidelines and templates? Are we tracking which prompts work well and which ones don't?
And of course, more tags. Prompt.type, prompt.purpose, prompt.template, and prompt.usecase.
Those tags help us organize our prompts and track their effectiveness. We can see which prompts are used for which tasks, which ones are most successful, and we can start building a library of reusable prompts.
So it's like building a toolbox of prompts that we can use for different scenarios.
Exactly. And this is an area where we need both the business unit and the enterprise AML Center of Excellence. The business unit understands the specific tasks and use cases, while the COE brings the technical expertise in prompt engineering.
Makes sense. It's a partnership between domain knowledge and AI expertise. What about storage? The table recommends Bedrock Prompt Management and DynamoDB.
Bedrock Prompt Management is a great choice because it's designed specifically for prompt engineering. It gives us a place to create, manage, evaluate, and even experiment with different prompts.
So it's like a prompt engineering lab where we can test and refine our techniques.
Exactly. And DynamoDB is a flexible and scalable way to store those prompts and all their metadata.
Okay, on to our final row for today. Evaluation metrics. We've built these amazing LLM and RJAG applications. We've made sure they're secure and scalable. But how do we know if they're actually doing a good job? That's where evaluation metrics come in, right?
Absolutely. Evaluation metrics are the key to understanding how well our LLMs and RGAGs are performing. They help us answer the question, are these systems actually delivering value?
The table suggests we start by understanding what metrics are currently being used. Are we using standard metrics like accuracy, precision, recall? Or do we need to define custom metrics for specific use cases?
It depends on the task and the goals. Sometimes those standard metrics are enough, but often we need to get more creative and define metrics that really capture what matters for a particular use case.
And more tags. Metric.name, metric.type, metric.target, and metric.usecase. Seems like every piece of data needs a good set of tags.
They really do. Those tags help us organize and analyze the metrics. We can see how different models are performing, compare them against each other, and identify areas where we need to improve.
So it's like having a scorecard for our LLMs and our eggs, showing us how they're doing on different dimensions.
That's a good way to think about it. And for this, we need both the business unit and the enterprise collaboration team. The business unit knows what success looks like for each use case, and the collaboration team helps us collect and analyze the data to track our progress.
And for storage, we've got CloudWatch Metrics and QuickSight.
CloudWatch Metrics is great for collecting and storing those metrics. It's like having a heart rate monitor for our AI systems, constantly checking their pulse and alerting us if something is wrong.
And QuickSight.
That's where the magic of visualization comes in. QuickSight lets us create those dashboards and charts that help us make sense of the data and identify trends.
So we're not just looking at numbers, we're seeing the story those numbers are telling.
Exactly. Data visualization is key to understanding and communicating insights.
Great. Now we're on to feedback storage, which is all about collecting feedback from users and making our applications even better.
User feedback is essential for any software application, but it's especially important for LLMs and RAGs, which are constantly learning and evolving.
The table mentions that we should understand how feedback is currently collected and stored. Are we using surveys, feedback forms, just emails?
We need to make sure we're capturing feedback from all relevant sources and that it's stored in a way that makes it easy to analyze.
And more tags. Feedback.type, feedback.content, feedback.date, and feedback.usecase.
Those tags allow us to categorize and filter feedback, making it easier to identify trends and patterns. We can see what's working well, what needs improvement, and how different use cases are being perceived.
It sounds like we're building a feedback loop, where user input is constantly flowing back into the system, making our LLMs and our RAGs smarter and more effective over time.
That's the goal. We want our systems to be responsive to user needs and constantly evolving to provide the best possible experience.
And it looks like the business unit and the enterprise collaboration team are key players here.
Absolutely. The business unit understands the user journey and the desired outcomes, while the collaboration team helps us design and manage those feedback mechanisms.
Great. What about storage? The table recommends a dedicated feedback store for structured data and DynamoDB for real-time access.
The feedback store is the central repository for all that feedback data. It's where we store the raw data and analyze it to identify trends and generate insights. DynamoDB is great for those scenarios where we need to access feedback in real time. For example, if we have a chatbot that needs to adjust its responses based on user sentiment.
So we have a long-term storage solution for analyzing feedback over time and a real-time solution for those use cases where immediate feedback is critical.
Exactly. We need both to be truly responsive.
Welcome back for the final part of our deep dive into enabling 369 Superflight. We've covered a lot of ground.
We have data lineage, security, UI design, even prompt engineering, right?
Yeah, but as you hinted at the end of last time, it's not enough to just have all these pieces in isolation.
It's like having a toolbox full of amazing tools, but no plan for how to use them.
Exactly. So how do we bring all these storage solutions together to really support 369 Superflight?
Well, that's where the idea of a data ecosystem comes in. It's about moving beyond individual storage choices and thinking about how all these systems work together.
So we're not just building separate silos, we're creating something more holistic.
Precisely. Think of it like a city, right? You have different districts, different buildings, all serving different purposes, but they're all connected by roads, by utilities, by a shared infrastructure.
I love that analogy. So what are some of the key things we need to consider when building this data city?
Well, first and foremost, data flow. How does data move between these different systems? Are we using efficient pipelines? Do we have any bottlenecks?
Right. We don't want data getting stuck in traffic.
Then there's data governance.
Yep.
We need to make sure we're applying consistent policies across all our storage solutions. Think about data quality, security, compliance.
We can't have one part of the city following one set of rules and another part doing something completely different.
Exactly. And of course, we can't forget about metadata. We've talked a lot about tagging at the data element level, but how do we manage metadata at the system level?
Yeah. How do we make sure all those tags and labels and descriptions are consistent and meaningful across the entire ecosystem?
That's where a unified metadata layer comes in. It's like the central library of our data city. It provides a single source of truth for all our data assets, regardless of where they're physically stored.
So it's like having a master index that tells us what data we have, where it came from, how it's classified, and how it's related to other data.
Precisely. This unified metadata layer is crucial for so many things. Data discovery, lineage tracking, impact analysis, even AI model explainability.
It's like having that bird's eye view of the entire data landscape.
Exactly. And it allows us to move beyond just managing data to actually understanding and leveraging it for insights and action.
This is all incredibly fascinating, but it also sounds pretty daunting.
It can be, but don't let the complexity overwhelm you. The key is to break it down into manageable steps and start with a clear vision.
So where do we begin? What are some practical first steps for building this data ecosystem?
Well, as with any major project, it starts with defining clear goals. What are we trying to achieve with this data ecosystem? Improved decision-making, faster time to market, reduced risk.
So we need that North Star to guide our efforts.
Exactly. Then, once we know where we're going, we can start mapping out our data flows. Identify the key systems and storage solutions involved, understand how data moves between them.
So it's like drawing the blueprints for our data city.
Precisely. And as you're designing those blueprints, don't forget about data governance. Establish those clear policies for data access, data quality, data retention, security. These policies act like the building codes for our data city, ensuring that everything is built to the right standards.
And as with any construction project, I imagine collaboration is key.
Absolutely. Building a data ecosystem is not a solo effort. It requires close coordination between different teams, IT, data engineering, data science, business stakeholders. Everyone needs to be on the same page and working towards a shared vision.
Well, I think we've covered a lot of ground in this deep dive. We've explored the individual storage solutions, A&D, how they fit together into a broader data ecosystem, all in service of enabling 369 Superflight.
We've seen how the right storage choices, combined with a thoughtful data ecosystem, can truly empower our LLM and RAG applications.
It's been an amazing journey. Thank you so much for sharing your expertise with us and our listeners.
It's been my pleasure. And to everyone listening, keep exploring, keep experimenting, and keep pushing the boundaries of what's possible with AI and data.
We'll be back soon with another deep dive into the fascinating world of AI. Until then, keep innovating.